Annyeonghaseyo. Welcome to the Gameplay Framework Simplified in action. Who I am? I'm Radu. Hi. I am a lead game designer at Flying Wild Hog, working on a few projects in Unreal Engine 5. I'm also one of the chapter leads at the Unreal Engine community in Sweden. I have been working for 14 years in the gaming industry. Here's a few of the titles that I have been working on. And in the past, also, I have been the head of game design at a school here in Stockholm, where I created a curriculum and also taught. And more recently, I have finished Epic's bootcamp training called Unreal Fellowship. You can find more information about me at my website, bradu.org. Now, to get into it, we will of course talk about the gameplay framework. Here on the right, you can find the full schematic of the framework, and we will start by understanding the framework via simplifying it, but also simplifying the theory, and then showing it in the editor. In the second part, we will make sure we have a common vocabulary, and with that we will explore complementary concepts that will allow us to put the framework to good use. And then in the third part, we will modify, create, and prototype. The modify part is actually very important because we will learn to lean into the strengths of the engine. We will not try to reinvent the wheel. All of this will get combined into a small game prototype. And to be more specific, I'm talking about red light, green light from a known TV show. If you're seeing the colors below these shapes in a different tint, this is just an accessibility thing. We will use the same color coding throughout this presentation. Also good to note, since we have 3 chapters, the first 2 are generally short and introductive, and will also include vocabulary used in Unity, if you are familiar with that engine, to allow for easier accommodation with the terms used. In part 3, we will actually build with the framework we just learned in the previous chapters to create our little game. Overall, this is meant to be like a general introduction to Unreal if you are new to Unreal. Now, we will use, again, a simplified version. This is the schematic that will follow through. And inside of this, we will have the game mode, the player controller with the HUD and input, the pawn with the camera, and we'll use 2 general methods to simplify things. First is an analogy, a very simple one, to something we all are familiar with, which is the human body. And then second, we will use in layman's terms, which means in plain English, in just 2 words explaining the concepts. When you see this arrow and that colored font, we are referring to the simplified version of what this concept means. If you are seeing this Unreal logo in the middle of the screen, means we will go in the editor to look at things. And lastly, all of this is on top of the third-person template, very standard in Unreal. I'm using Unreal Engine version 5.6.1, but not to worry, even if you're using some other Unreal 5 engine, probably even 4, all we're discussing here should be perfectly compatible. Now, to get into things, the first one, the game mode, simply put, sets the rules. If you are coming from Unity, this is kind of like the game manager or like a scene manager. And the relationship to the human body is like the DNA. Now, we will go into the editor to look at things. As mentioned, we have the basic third-person template here. If you see maybe a few of the behavior that is changed, the only 2 options I have changed here are in editor preferences. I changed here to open new things in the main window. New windows will appear here. And then the widget reflector, this is just so everybody can see a little bit better. I put it to 1.4. You can find both of these options, one here and the other one here. Okay, so now to get into the specifics, the first one, we had the game mode. So this is the game mode. I opened it up and we're presenting with a bunch of information. Don't fret. It seems like there's a lot on the screen, but here's kind of the nice thing. You can do a lot with a little in Unreal. And you already see some things we briefly touched upon before, which is like the controller and the HUD and the pawn class. Also, good to know that the game mode is plugged in the world settings here. So this is specific to our current level that we're in. So you'll find all this information here. But also we can find more project related settings, more global in some sense, in the maps and modes. And it is here. Okay, going to the next term we have, and it is the player controller. This interprets actions. If you're coming from Unity, it's similar to Unity's character controller component. And it's kind of like the brain. If we're going now to the editor, we will see, we'll actually start from the game mode again, because I want you to see that we have, as mentioned before, all of these linked here together, which is very nice. If I click on this little magnifier glass, it will take me straight to where this is actually found. And if I open it up by double clicking it, we will see that this is our player controller. We don't yet need to go into the details here, but we already see something related to input, which maybe confirms the aforementioned interprets actions of the player controller. Next, we have the HUD, and it displays the status. If we're taking the human body parallel, it's kind of like the vitals. Think of it if you're like in pain or you have an itch and you need to scratch it. This is kind of like how it works. And if we're going to check it in the editor, we will again go back to the game mode and start from there. And when I click on the magnifier here, you will see that actually it doesn't point to anything in this folder. And initially you might think, this is maybe a problem, this is a bug. But actually it is not. When we get into the third part here, we will actually have pretty much our first stepping stone to learn how to understand the meaning of the HUD. And if we want to sort of take an example of what could be HUD, heads-up display, or UI, user interface, here in the corner of the screen, you see these coordinates, right, where my mouse is. And this coordinates, it's kind of like HUD, like UI on the screen, because it's pinned on top of the screen. Cool. Going to the next one, we have the inputs. And these trigger actions in the human body, like the nerves. And going into the editor, inputs, we already saw something in the controller here. So we will, as we see, we have something related to inputs here. And also, if we press the same, find the magnifier glass, and we press it here next to one of the input mentioned things, we'll see a bigger folder with inputs. We will get to work more in detail when we get to chapter 3. Then the pawn, which performs actions like the muscles in the human body. And then we will go into the editor, again, starting from the game mode. We will find here the pawn, but here we actually see it is a character, not a pawn. Simply put, the character is like a more advanced pawn. If, for example, you'll have something that you want to interact in the physical environment with, movement states like walking and falling and swimming, you probably want to use a character because it has all of these things already embedded into it. And again, we click the magnifier and we find it. And here we find a bunch of things related to, again, actions, as we said before, that it can perform. Then last, we have the camera. It adjusts the view. And in the human body, of course, the eyes. And if we're looking in the editor, we will find here, back where we were before, in the pawn, that we have a camera here. And if I go into the viewport here, and I just pan around, I press A to kind of move the camera while I hold the right mouse button, I can see this is how I will see the game from, the angle that I see the game from. And I can even drag and drop this into here, and you'll see in this little preview, this is literally how I see the game from. And since we went through all the major concepts of the simplified gameplay framework, I will hit play here at the top, Alt-P as a shortcut. and we will see everything we just talked about. So one, the camera. I'm just moving the mouse around, so this pans the camera. Then in the middle, I have, of course, the pawn, which is the physical interpretation of, our pawn, our character. Then when I press input, as you see in the bottom right corner, I'm pressing W and then D. This moves the character forward via the nerves, the input. And of course, the controller is the brain that holds all of this together. And overall, the game mode holds every other piece together, like the DNA. I'm pressing delete now to close it. For you, it might be escape by default. This is just a custom changed key I have. Now with that, we are done with our first chapter. To recap, we simplified the framework. We explained each term in layman's terms, in plain English, and then we verified it in Engine. Now, getting to the second part, the vocabulary. And you might still wonder, why are we actually tackling this? But the reason is really, even knowing some of these few things that are adjacent, complementary to the gameplay framework, will really enable us to use it in, for the betterment of the end result. So I'm going to start with, we have a few categories here, but really I'm going to start with something we're exposed pretty much as soon as we open the editor, which is the editor interface. So we have toolbars, again, access tools. We have the viewport, views the scene. If you're coming from Unity, this is like the scene view. Then we have the outliner for organizing the actors in like a tree view. If you're coming from Unity, like the hierarchy. Then we have the details, allows us to edit various properties of our selected actor or actors. And if you're coming from Unity, it's like the Unity's inspector. And then we have the content browser, which allows us to manage assets. It's pretty much like a file explorer, and where you can drag and drop things. We already did this in the previous chapter a little bit at the end. And if you're coming from Unity, this is like the project panel. Now we're going to go into the editor to look at these things. First, we have toolbars. So toolbars, we have a bunch of toolbars all over the place. So for example, we have here toolbars. We have here at the top a bunch of other tools. Tools vary in the range from allowing you to move, rotate, and scale things, to allowing you to verify your performance, or what sort of properties things have, and so forth. Then secondly, we have viewport. This is a named tab, so it's very easy to identify. As you can see, the viewport here is what we see in our level. By me holding right mouse button, I can just pan around. Then we have the outliner, which is again the tree view of everything we have in the level in a nicely organized way. Then we have the details. If I select an actor here, you will see I see properties of that actor. And last, we have our content browser, which again is like a file explorer. Not everything that is in the content browser here necessarily needs to be in the level. So this is more general files you have in your entire game, not necessarily in the level. Also, you can have a very nice shortcut to open the content browser on top of other things by pressing Control and then space. And this allows you to sort of open it on top of other things. So very handy to have. Cool. Next, going to the general category, we have the actor, which is something that exists in the world. This can be like a character, a light, a tree. It can even be an invisible trigger, as long as it exists in the world. If you're coming from Unity, it's like the game object. A class defines the type. It's like a template, like a cookie cutter that defines what the new object will be like and what it can do. If you're coming from Unity, it's like the mono behavior class. Then we have the component, which adds a feature. This can pretty much, it's like a plug and play. It gives an actor or some blueprint a new ability, like maybe being able to move or making a sound or VFX. Then we have variables, which are containers to store values, and these are there's quite a few of them. I'll take some examples, like a bool, which is a true or false. Then we have a vector, which could be the location of something. Then we can have the character name in a text or a string, and many more. And lastly, we have blueprints, which is a very general concept in Unreal. It refers to multiple things actually, and this is for building logic. Simply put, visual scripting. Instead of using C++, which is the code behind the visual scripting, we're using a bit more visual blocks to build our logic. If you're coming from Unity, it's like Unity's visual scripting, which before it was called Bolt. Now, looking into the editor, we will see here we have an actor, right? We already actually have selected, and you can see here the name says actor for all of these. Then we have a class, and the simplest way to actually talk about the class, we can check the character, and here in the top right corner you will see that the character is the actual parent class. Then components. In here, everything in this list, which is even named at the tab above, is called a component, and again this adds various features as mentioned before. Then we have a variable. We can create even a basic one to talk about. So for example, we have Boolean, we talked about, it's either true or false. Holding Control-Alt, very useful, it gives a bit more information. Then we have a float, integer is like a full number, like so. And a name, a string, and so forth. Quite a few of them, as I said. And then generally speaking, blueprints are here in our, if we go into our event graph, right? This is generally where we put the logic that we have in our game, right? And yeah, we will get more into details as we get into our third chapter. Next, we have, as I said, blueprints is quite a big concept in Unreal Engine, so we will talk quite a bit about this. And specifically to blueprints, we have the construction script. This does preliminary setup. If you're coming from Unity, this is like the onStart or awake method. Then we have the event graph, which runs logic. And if you're coming from Unity, you have the script graphs there. Then we have nodes for executing actions. This is like puzzle pieces coming together, and you connect them, and it makes the game logic. Then we have events, which is pretty much the start of something. It triggers responses. Like it triggers a chain of responses usually. For example, if you press a button or something collides with something else. Then we have flow control. This allows us to guide logic throughout these nodes. And here a very general example, which is quite known, is an if statement. If something happens, if it's true, you do this. If it's false, you do that. And lastly, blueprint communication, very important concept, allows you to share information. So different types of blueprints can talk with each other. And it's like communicating with someone in a language they don't understand. We need some sort of translator in the middle that allows us to do this, and blueprint communication is specifically for that. We have various types in Unreal, like casting and interfaces and the event dispatcher, but some of the counterparts from Unity is like get component for casting and exposed Unity events for event dispatchers. Now, to look into the editor for these things, we have the first one is the construction script. So here, this happens very early, before anything else. And we will, again, in chapter 3, start working with this a little bit. Then we have the event graph, which just has the main logic you can build. Then we have nodes. Nodes are anything like this that are these blue ones. Then we have events, which are these red ones. Again, as you see, is the start of something. Then we have flow control nodes. I can take one in visual scripting in blueprints in Unreal. It's called an if statement. It's called the branch. So as I said, if some condition, if this is true, do this. If it's false, do that. And then for blueprint communication, casting is a very common one. I'm just going to take something random here. Here I'm checking this specific object. Are you of the type rect light component? If you are of that type, I can understand you, I can talk with you, I can get properties from inside your type. And with that, we go to the end of our chapter. To recap, we identified the adjacent and complementary concepts. We explained everything in simple terms, and we verified it in Engine. Now we get to our last chapter, which is a very hefty chapter with a lot of in-editor, in-engine work. But before we get into things, let's actually make sure we understand something. What is our end goal? always when you sort of learn something, it's nice to identify kind of where you're going, not just to go blindly in the dark. And, you know, with the exception of course, we're talking about the gameplay framework, we're learning about the gameplay framework, we're also using the framework to build something, a little game, right? So in our case, red light, green light, all right? So you go, you stop, and then you go again. So this is already a game. We'll see what we can do through the lenses of the framework to make it a bit more interesting. And here is like a snippet of what we will actually build in this chapter. Now, to make sure we don't end up with something like this, which is something that is kind of half-baked, we will ensure that we actually know what our goals are. So we probably need movement, right? It seems quite important for this type of game. We want a win and a lose condition, so the player kind of knows what they need to do, and the game kind of feeds that to them. And then some sort of challenge, so the game is nicely balanced. And hopefully we end up with something like that, a little bit nicely drawn horse. Now, to recap a little bit, we're talking about this, right? This is what we're gonna build on top on. And now we go into the editor. So let's start from the things we just talked about. I'm gonna start from the game mode. So if I'm not mistaken, we went through everything previously, we looked at everything, but there was one thing that, as you remember, hopefully, was the HUD, that actually we didn't find anything related to that, and it was a bit strange. But as I said, this is pretty much the first step to build our, let's say, our detective skills, a way to really understand how to problem solve yourself. And, you know, you can call it debugging at times, but it's really how to think about things. So let's see, what do we know, you know, like a detective? What do we know about the problem we currently have? Right now, we know it's a HUD class and its name is called HUD. So I'm gonna go here, back into where I have all my project files. I'm gonna go at the top and I'm gonna search for exactly that, HUD. And we'll see here that there is just one that has the exact name as we just wrote it. And we probably can now tell why this didn't really open up. It is a C++ class. C++ is the actual coding language. And for example, if I would double click this would just open the code editor, which we won't bother with in this presentation because we want to learn how to do this through visual scripting. But this is actually the reason why it didn't manage to link to something. It still knows that it's using the C++ class, but it's not something that you can visualize in the editor. You can visualize just blueprints mostly here. So let's start. This is a good first step to actually build our first blueprint. So I can do it from here. I can right click and create a blueprint class based on the HUD. I can also go maybe in the game mode and I can click this little plus next to it. It will create a type of blueprint of this type, of this class. But I think one of the more common ways is to just go where you have most of your things and create a blueprint class, right click, blueprint class. It's not in the common one, so I would expand this, search for HUD, pick the HUD, select, and then I'm gonna name this. As you see, everything else has very nicely made naming, so we'll use the same naming convention because this allows us to organize a little bit better. So BP HUD, probably a good name, and there we have it. We created our first blueprint. With this, now we have all the basic components for all the basic parts. Let's not call it components, since components is something else. All the basic parts of the framework. Now we can go maybe start from the goals, right? So I'm gonna just take the goals and actually put them somewhere here in our in one of our blueprints, maybe in the pawn. It's probably good. I'm gonna put it here at the top. I'm gonna right click and say add comment, right? This is one way to add a comment. Also a simplified way is pressing C and this spawns a comment, and I'm just gonna paste our goal, so we don't need to go back to our presentation back and forth. So now I know that these are kind of the main things we're following through. So let's, of course, start with movement. So let's think what we can do first for our movement. Maybe we can play the game again. So I'm gonna play from here, and I can move, I can do this, I can jump, which may be also useful to have with space. So maybe I want to be able to change my speed, change the speed that I'm going at. So here's how to do it. First, I'm gonna go to my character movement component. Sounds very much so related to that. And I'm gonna search for max walk speed. And we want the normal one, not the crouch one. And let's say I'm gonna change this from 600 to maybe 100, right? I should be able to feel this. Before we do that, I wanna introduce a very important concept, which is compiling your blueprints. This is not like saving. You might think it's like saving. Saving is even here next to it. There is actually an option in the engine to do both at the same time, but compiling is something particular. So for example, is before you submit your homework, right, to be reviewed, someone else kind of checks it. Maybe it's your mom before you go to the teacher. It verifies if what you did in the homework is okay. So compiling works like that. It automatically sort of checks out, tests what you sort of have in this blueprint. And if it finds any weirdness, any problems, maybe you connected some node to something off, it will, it will tell you. So when it's yellow, it says it's dirty, it needs to be recompiled. If I click compile and you have the green checkbox, means everything's cool, we're fine. So even when we play, I believe it automatically compiles everything, but it's also good to know that sometimes when you have an error, you should go back to this and see sort of in the compiler results down here, maybe what is the error. So now if I play, right, I put it to 100, and now if I go forward, press W, you probably can tell the difference, right? It's very much so slower. But great, now we know that that is where we want to do this. I'm gonna reset this from here. Pressing this little arrow is a nifty way to do it. And I will start with doing our first event, which is a very common one. We'll use this quite a lot. It's called begin play. As the name would imply, begin play happens when I press the play button, right? You probably remember we talked about construction script, where it happens very early. So construction script is first, it does everything, and then there's a bunch of other stuff that happens in the background, but really, for the sake of the discussion, really it's construction script first, and then it's begin play. So here I want to do actually very similar to what we did before, but just to start building our logic here. So I'm gonna drag and drop this, and I get the character movement, and then I'm gonna search exactly the same as before, max walk speed. And you see probably here we have two types, and maybe we should explain what's the difference between a get and a set, right? I will want a set in my case here, but the difference between a get and a set, if I do again max walk speed, and I do a get, right? You see they look quite different, but simply put is if you're in a car and you read the speedometer, like how fast you're going, that's a get, right? But the difference to set is when I press the acceleration pedal, this updates the speed, right? And that is a set. So the difference between get and set, get is reading the value, set is updating the value, right? So very important concept to know. Also for future tense, if you want to quickly get something, you can do it by, I'll just do it with a quick variable here. I can do it either by this, and it will ask me, do you want a get or a set? But also you can do control for a get and hold alt for a set. Very nifty to have. All right, cool. So let's plug in this, and let's again set this, maybe not to 100, that was extremely slow, maybe 400. And let's see how this looks like. I didn't compile, but you'll see when I click play that it will still update. Okay, so I'm doing a little bit slower. Let's put it to 600 so you remember what was the difference between the two. Right, so you can clearly see 600, and then 400 here. And with that, we can probably also demonstrate we talked a little bit about construction script and events that happen in begin play, but nodes that are connected to begin play. But let's actually see this in action. I'm gonna just copy paste this in here, and I'm gonna call this one 100. So I'm gonna say in construction script, I want the speed to be 100. So we know that it's really slow. And here I leave it to 400. Let's see what actually happens when I play. So we see now the speed is not 100 as it was in the construction script, is 400. So this demonstrates the actual order of things. So construction script first, then begin play. So if I delete begin play, the nodes I connected there, and I compile now, you will see, and I play, you'll see it is actually taking from construction script. But before, when I had it like this, construction script, everything that I did in construction script was just overridden but what I did in begin play, because it was of the same type. Cool. So with that, we probably can get into input, right? So for input, we want to start from, if you remember, the controller had something related to input in here, and maybe it's good to start from here to understand how to work with input. So here it says irregular input mappings. And before I do more here, right, I see touch, control, skip, mouse look. Okay, cool. Before I do anything, I want to teach you another thing that I would consider in the part of the detective skills, which is disconnecting things. So for example, here in the sequence, also good to know, hovering on things gives you some information, especially when you hover on nodes. Yeah, Control Alt, of course, gives you even more details. So that's very handy to have. But yeah, going back to disconnecting nodes, I'm just going to disconnect everything that's here. And I'm going to pretty much try it out. Let's see what happens. I'm clicking play. I'm going back to my game, and I'm moving my mouse. I am pressing W. I'm pressing S, A, D, nothing happens. Space, nothing happens. So this means that whatever I just disconnected is vital to make inputs work. That is very good, because now we sort of confirm for ourselves that that is important, and we want to continue to use this. So going back here, we will check where this is. Again, using the magnifier glass, really good way to find your way through things. Another detective skill. So I find EMC default. Let's open this one, see what it is about. We know it's a mapping context. In here, if I expand mappings, I'm gonna see that I have a bunch of things, which is jump, we know about it, move, and look, and so forth. So we have even alternate ways to do some type of movement. And that is good. I also want to check a specific one, like jump. Let's see, how is this jump made? And I'm gonna, again, click the magnifier glass and open it up. And really what I am interested from here is it's of the type digital bool. There's multiple types here. We'll mostly use digital bool in our case, because a jump is very similar to what we will try to do. So what we will try to do, since we just started tweaking speed and working with speed before, we probably want to try to do running, like sprinting, right? So I'm gonna do exactly the same as I had in the other one. So I'm gonna go to inputs, input action, gonna call it again using the same nomenclature, the same naming, IA run. And in here, it is a digital bool. Awesome, that is the one I want. And I'm gonna make sure that in AMC default, in the context, I also add it. I'm gonna click plus on the mappings and then select it here. And as before, you see all of these ones have some keys attached to it, and I want to do the same. I'm gonna click on that and press the button I want. In my case, shift. And with that, we are good. As you see, the mapping context is kind of like a folder that holds all of these keys together. It's like both a folder and a key, I guess. And if this would be completely empty, this will do nothing. So it's an important concept because it holds everything together, but it needs to be populated with actual keys to have access to those inputs. So now that we added it to the context, let's actually try to use it. Going back to our character, I'm gonna go into the event graph. I'm gonna actually take this with me because I think I'll need it very soon. And I'm gonna right click here and I'm gonna search exactly for the name of what we just made. You'll see two things here. One is the value, which is pretty much the specific value of this property, but really we want the event. We want the start of how this actually happens when I press the button. So there we have it. It looks very similar to the jump, for example. If I even hover on this, again, hovering, super useful. You see the details there. So I'm gonna also show you another very simple way to try out things, to test out things, and it is using a print string. So if you want to quickly test if something works out and you don't want to add the full logic here, just using a print string is super useful. So I'm gonna click play again, and here I will actually press W, and then I'm gonna press shift, and I'm holding shift down right now, right? And it just says hello constantly, right? So this means that it casts continuously as I'm holding the button down. So that's great. Now I'm gonna also want to expand this. You see some of these have a little expand button that I can get more options there. And with that, I see that I have multiple execution pins, and we pretty much didn't talk about execution pins, but really it's basically where the logic connects to each other, right? So for example, here I connected this one to the print string, and this is how, you know, I know that this is the next step after the trigger of the run happened. So I actually want to test some of the other ones to make sure that I understand how they work. So let's, for example, take completed, right, to see if there's any difference between triggered and completed. So I do the same, I go forward and then I press, and I'm right now holding shift, as you probably can see it here, and I'm releasing it. And when I release it, because it's on completed, I hold and I release it, only then I get hello of the print string. So the difference between these two is that one is continuously active and the other one happens only after everything's done, when the action is completed. And this is perfect because this is exactly what we need to create our run. So I'm gonna paste this once and twice, and first I'm gonna put one in triggered and second one in completed. And let's think about it. When I hold shift down, I should be able to run. So I want my speed to go higher. And when I release shift, then I want the speed to go back to the default, which in our case, it's 400. Let's try this out. And I go forward, I go to my normal 400, and then I hold shift, and suddenly I start walking. I release shift, right? And basically I go at normal speed. I release shift, I hold shift, I release shift, I hold shift, I release shift, right? So now we have like a workable run. Since we started, you probably see that we test the game a lot after our changes. Very much so recommended to do that. I would say also important, since we're doing this a lot, anything that you realize that you're doing often, think about, again, another detective skill, think about just simplifying it, giving you some sort of fast method to do that. And in our case, I'm talking about adding a restart button, right? So maybe we want to retry a bit faster. So with that, I'm gonna do exactly what we did before with our run. So let's also practice doing inputs. If I go back here, I'm gonna write, I could even duplicate this and call it restart. I know it's of type bool, right? I can open to check. So that is good. That's the type I want. It's just a bool is just like a true or false. It's either pressed or not pressed. And make sure I add it in the mapping context, which I might have closed. Yep. And then I add the mapping context here. I press restart. And with this, I will do R here. Seems very much so for the purpose of restarting. And with this, I'm gonna go back to my character or my pawn, right click, IA, restart, pick the event, and then I want just to complete it. I don't want this to be too spammy, and I want, in order to restart the level, one of the simpler ways is just to open this level again. So I'm gonna do by name. You could do it by just writing the name, which is this one here, right? Level underscore third person, but keep in mind, you really need to write it exactly as it is. Anything wrong here, as I just did, could just not make this not functional. Another way that I would recommend you do it is to just right click here and get current level name. And with this, I will connect it to complete, and then I will connect it here. And then I want to connect these two nodes. You probably can tell that one is name and one is string. The difference between the two, very easy to tell. Again, doing Control-Alt, super helpful. If I put it on string, it says string is a piece of text. And if I put it on name, it's text name. And comparing two names is faster than comparing to string. So now you know that they have some specific properties. I'm going to try to convert the two. I'm really smart enough to know, hey, these are two different ones, but I can still convert it for you, no problem. And there we have it. I'm going to compile, play. I'm going to move a little bit around, jump, and then press R. The game restarted. Again, I'm going to do something, press R, game restarted back from the start. Great. So with that, we improved a little bit our workflow. Again, another detective skill in our toolbox of skills we are learning. Probably now we're good on movement. Let's try to work a little bit with the UI, with the HUD. All right. So I would focus first on what did we have here at the top. If I go here, so we did movement, right? I can exit or delete it or whatever. And then I have win-lose condition. So yeah, that's probably something we want UI for. Oh, also commenting, as I said, very important. So let's try to actually follow through. So this is run movement, and this is debug restart. I can also make this a little bit longer, and with that I can also move these around, which is also helpful when you add a comment. I can't grab it. If at any point throughout this presentation I forget to comment something, it's just to, you know, buy a little bit of time to, you know, not add the comments and so forth, but really recommended to comment. As you see, all of the other things here are commented as well, so really nice to explain a little bit what you're doing there, especially if you have a bit more complex logic set there. Okay, so let's talk about the win situation, like the win condition. For the win condition, if we think about red light, green light, we had something like in the TV show when one of the runners was passing some certain threshold, they would be considered successful or they won, right? So we will take that as our first kind of win condition, let's say. And I'm gonna go in here, third person, blueprints, right click, and we are gonna create our first user interface. And I just want a simple user widget here. I'm gonna use WB because it's a widget blueprint, right? So it differs a little bit from the blueprint. And I'm gonna call this just win. It's probably fine. Gonna open it. And in here, you will see it looks slightly different than what we sort of had before in our regular blueprints because we have a designer tab. But if I go to the graph, you pretty much see like the general event graph. We're gonna though work mostly in the designer here. Yeah, so let's build visually what we want to show when you actually win. Most people would start here actually from a canvas panel, which is a quite commonly used one because it's it's pretty simple to use it. You can just throw things inside it. But let's actually use good practices and do an overlay. The difference with from canvas and overlay is a bit more less performance heavy, and it also allows us to pin things a little bit more specific to the screen. And in here, I just want a text, right? So I'm just gonna drag and drop a text on top of the overlay. Right now, it is in this top corner, but I want to actually use the anchors to center it very nicely with the anchors. Then I'm gonna change the text to be, I'm gonna zoom in a bit, probably U1 is pretty victorious to me. I'm gonna put it in green. Green is usually nice. Change the font size to maybe 40. And if we want to be a little bit fancy, put a bit of outline, just black outline. You can change this, of course, if you want to. And then I'm gonna compile. And with that, I have my first Win UI. Now, this is all nice and good, but I also want a physical representation of this end goal. So I'm gonna right click here and create a blueprint class of type actor. I want to have physical presence, right? So actor. And I'm gonna call this pp underscore maybe win trigger. I'll open this up. And as I said, I want when the user, the pawn, passes its threshold for something to trigger. And with this, we're talking about collisions. So I'm gonna add a new component. Again, a component adds a new feature. So I'm gonna search for collision, and I want just a simple box collision. Also good to rename this so you don't confuse it with something else. I always like to do that. Good practice to do so. And here I want to extend this a bit. You could technically use the scale here to do the same, but since we're talking about collision, it is very much so recommended to use the box extent. It's a little bit more accurate in that sense. Let's do 200. It's 200. It's probably good. And then 150, 125, 40. Yeah, I mean, I think that's probably okay. And then I also, this collision is actually invisible. There is nothing you would be able to see. As you see, it's just like a kind of empty box there. So I also want to add something visual, and I'm gonna add just a cube. This is just a static mesh, very, very simple. And I'm gonna put it up here. And I'm gonna make sure I reset these. And I want I press the shortcut keys to change from move to scale. So it's basically, as it says here, W and E to rotate and R to scale. So I'm gonna make it a bit like this and then elongate it a little bit more. Then I'm gonna move it, go back to W and there, maybe give it a little bit of some color. Again, I'm assigning a material. A material is like a surface to something. If it's, you know, some specific color, if it's shiny, if it's metallic, so forth. And with this, let's actually drag and drop this into our world, to our level. So here I'm gonna put it and I'm gonna rotate it. 90 is probably good, and then put it higher up and try to position it kind of on top of the ground. Green on green, probably not the best way to read this. And since I don't want UX designers to come here and flip my table, let's change this to some other color. Let's do blue. By the way, I'm just searching for colors here, and it might seem like you find any color you just write. And that's actually not true. You find some of the basic colors in the engine content, but this is just some of them that are reused, for example, for the animation sharing base, right? And I'm just reusing this for, you know, for just being a bit fast with using some different colors. Okay, great. That's awesome. And now I want to maybe first test if this works out nicely. And as we talked about before, the HUD and UI sometimes sort of interchangeable in the general concept. You know, the heads-up display and the user interface is stuff that is pinned on the screen, and the HUD is kind of like the input mapping context. It's like a folder that holds stuff, but without adding things into it, it doesn't do a lot. So we're gonna do just that and add it. You can generally add UI anywhere else. It doesn't need to be in the HUD, but we're learning good practices here. So let's put it into the HUD. So I'm going into the HUD, into the event graph, and right here, I will do just that. If I can drag here, I'm just gonna delete these two, and I'm gonna do create widget, and I'm just gonna add the one we just made, which is called WB win. And in order to actually make sure it shows, I need to also add it to the viewport, right? The viewport, as we said, it's pretty much what you see on the screen. And with that, let's test it. And there is nothing. What did I miss? The win, the owning player, the HUD, the viewport. Let's look into this one. That seems correct. And now if we go into the HUD, we should see it. Let us try to investigate our problem. So we have made a widget blueprint. We have some text on it. We have anchored it. It has some color. That seems okay. We have it here. And with that, we also have the win. Yeah, this should generally work. Did we maybe not compile this? U1. Let's see. Somehow we don't see it. Let us try something else. Let's create it from here. Oh, I realized what we didn't do in the start. Again, this is a very good learning. If we go into our game mode, you will see that we still have the old HUD. We did not actually connect it. So now you should actually be able to see it, right? So again, always retrace your steps. Make sure, you know, we did create our HUD, but we actually didn't connect it to our DNA, our game mode. And this is, again, great detective skill to have, you know, always retrace your steps. So great, now that it works, I want this to be not just to be U1 at the start when I play the game, right? This was just a test, but I want this to be placed into a specific event. So with this, I just cut those, and I'm gonna create our first custom event. I can say custom event, and a simplified way, which I like to use often, is T dot, because it's just the ending of that. And custom event, I'm gonna say show win UI, and I'm gonna just paste it. And with this, when I call this specific one, I will be able to actually get, you know, to show the specific UI that we are talking about. So in here, in the trigger, I want to do exactly that. We did a collision, we have it, it is ready for us, but we didn't add anything to it. If we right click it here, we can get events that are relevant to it. You might think hit is the one you want, or something that sounds very good to use in this case, but actually hit doesn't help us because it's more related to physics and solid objects, and actually doesn't help us at all. But begin overlap is the one we want. As always, there's multiple ways to add these things. You can also go scroll here and go from here. You can right click and search for it. I generally like to right click the component because I know specifically what I'm spawning, what event I'm spawning. So from here, I can, for example, first do a print string as we learned before and just check if this works. I'm just gonna run and pass into it, and just says hello, hello, perfect, so I know this works. But now I want to actually connect it to the things we just talked about. First, we will actually cast to our player. This is not particularly needed right now in our game, but is a good practice to make sure that only when our player crosses this box, this happens. So for example, in the future, if I'll have multiple actors that can pass before me inside of this, and they will win, and let's say there's a limit of how many players can win, then it could be a awkward situation where something else passed and I got the message that I won, which is not correct because I actually didn't went through the win trigger. So because of that, I want to cast. I'm gonna take the other actor. The other actor is pretty much I have the collision box, and then whoever else steps into it is the other actor. And then I'm gonna cast to our third person character, like our pawn. And this confirms that it's me. I can also check it again with a quick print string, make sure it works. Do the same, jump there, everything works as before. Great, we tested it. And now I want to sort of get the HUD, right? Because we added that event in the HUD and I want to trigger it from there. As we talked in the start, the HUD is kind of part of the controller, so we will need to get the controller first. All of these you will find with ease because they're kind of based on the game mode. So you have some kind of common base to find all of these. These are not the casted version. For example, this one, you see it is a BP third person character. And if I get the pawn, you will see that this is just a pawn object. So these are very different from each other. And this is why casting, again, is important. And I will get the HUD from here. And again, to highlight why casting is important, we just did this. I have an event here, show win UI. So technically, right, I should maybe be able to get this. So I'm gonna do show win, and it doesn't seem like it finds anything. Again, relating to the importance of casting, I need to get the specific type. And from this specific type, if I connect it to that one, I have this one. So now, hopefully, a nice example to see why casting is important, this handshake between these two. Without that, we would not know the specific type, and we would not be able to get the specific custom event we just made. Okay, let's test it out. Let's go there. And you won. Great. So that works exactly as we wanted. Great. Now, for the next part, maybe we should investigate the losing scenario. In order to buy us a little bit of time, we're just gonna duplicate the win, and I'm gonna call WB lose, and double click this. I'm gonna select this one, call it you lost, probably good. I'm not gonna leave it on green, make it red. Red usually not good. And I'm gonna compile it, leave it as such, and go into the HUD, create another custom event, call it show lose UI. I can duplicate this. Again, you kind of see the flow where we're doing a lot of repetition here just to learn the concept well, and trying to reuse something or use the same concept again and again will kind of solidify it in your head. Really recommend to do this, especially when you learn new things. And with that, we have the lose UI. Great. And now let's think about how you actually lose in red light, green light. Well, there's a bunch of methods, but let's pick one at first. The method that I think was pretty common in the game was there was a timer, right? There was the concept of a timer, and if this timer would run down, you would lose, right? So let's use that as our main lose condition. So now, as we talked about the timer, we probably want to have like a specific UI for it. So let's do just that by right-clicking here, and then we do another widget blueprint. Again, user widget is perfectly fine. I'm just gonna call it UI generally. And inside of here, I'm gonna start with, as before, an overlay, drag and drop it. And now actually we're gonna learn to use another block here in our widget blueprint designer, which is a horizontal box. This will allow us to place multiple things next to each other in a nicely tidy way, like organized way, in like one line without us kind of tweaking every pixel. So I'm gonna add one text first and drag and drop it here. Text block looks good. I'm gonna I don't want to change the alignment here. I want to add some padding. The padding is just the the space in between the different corners or different screen points. Let's do 30 and 30 here. 30 left, 30 top, right? So it's not exactly in the corner. I think that's a bit strange. It's when it's purely in the corner. And then I'm gonna duplicate this. And this text, I want maybe just 15, right? And now I'm gonna explain why we did 2. We did 2 because we want one to be the actual text that says timer, so I know what these numbers are. And the second one, I want it to be, well, the actual timer. And speaking of the actual timer, I'm gonna call this actual timer. And because we're gonna use this, so we're gonna actually update the value of this, I want to make sure I check is variable. This will allow us to actually modify, this text. Great. So now let's start with what we did before, going into the HUD, making sure I add this. I want this always on the screen. I don't want it to be conditional. So let's just copy paste this actually. Again, a little bit faster. WUI. And with this, I have that. I'm pressing Q to align them. You can find all of these options, by the way. Also, there is something nice to do is to either distribute it or align it or straighten the connections, right? That's the shortcut I used. And yeah, let's give it a test. You see, I have timer in the top left corner of our screen. And yeah, that's great. It works. Now I want to make sure that I have a way to really update this, right? I want that text to actually be a timer. So with that, I want to go here in Begin Play, and I'm going to use something that is called set timer by event. And this one, I'm going to move these two a little bit so we have the space. So this one is something that will trigger some specific event on the amount of time I'm putting in here. So in my case, I want every second for the timer to get updated. And I also want to loop. I don't want this to happen just 1 second and then stop. And then from here, you see it's a red pin. Again, red relates to events. And I'm going to create a custom event. I'm going to call it update timer. Probably a decent name for it. And here, I actually want some numbers, right? And because I want some numbers, I'm going to create a new variable, call it remaining time. And the type will be maybe integer. Integer is basically a full number without fraction, and float is basically with fractions. So I want an integer. I just want pure seconds. So what we're gonna do here, it's very simple. Again, I do a get. I want to get, and I want this to be minus. And yeah, there's another simple way to do -1, but for the sake of seeing this clearly, I'm just using the this way. The other way is doing minus like this. It might not be as obvious that it actually does the same thing if I'm just putting one here, those two things, but I think that's a bit nicer for clarity. And then I want to set, again, I'm holding Alt, and I want to set this. So what happens here? Simply put, I have some time, which right now is a 0. That's no bueno. Let's do 30. And I want from 30 to decrease by 1, 29 seconds. 29 seconds is the current timer. And I want this to happen every second. So next time this gets run, the next second, it's going to be 29 minus 1, 28 is the new timer. And basically we just recreated like a timer. Otherwise, what else do we want here? probably we want to save a reference to our UI, right? So we made the UI here. I'm gonna move this. I'm just pressing the arrows, and I don't think we ever did this. Promote to variable, super nice thing to have. It's kind of like a quick way to get that specific type that's sitting in that pin and make like a specific variable that you can reuse in other parts. Because otherwise, imagine I'm just gonna say, hey, I want this somewhere here, and you can imagine it becomes spaghetti land and it's a bit unwieldy. So this is a nice way to just get a reference to something. I'm not gonna call it new var, I'm just gonna call it UI. And again, here I want the UI one, and because I right now I have the timer in the HUD, but it's just in the HUD. So I want the UI to actually update. The UI being the thing that actually has the timer, the actual timer, right? So now I'm going back here and I'm gonna get actual timer. And from this one, I wanna get I really like the name of this, set text, which might sound a bit funky, but it's actually very much so technically correct. If you go into the UI here, you will see the type we have here is text, and the property we have here is called text. So it is technically set text. And here I want to connect it to that and make sure I connect this to this. Again, it is converting, two different types to understand each other. And I'm really smart enough to know that that is not of the same type, and it converts it. Great. I think that is good to try it out. Let's actually do so. Yeah, as we see, the timer in the top left corner, it decreases. That's awesome. That's what we wanted. We can also try to go a little bit faster. Instead of 1 second, I'm gonna just increase the, instead of every second, every 10th of a second in this case. And you'll see it goes to minus. That's not great. Let's actually fix this. Every time you have things that are kind of running over time, like a timer or a tick, which we will actually explain a little bit after this, we should make sure we clear it, right? So what I'm gonna do from this timer that we made here, I'm gonna again promote it to variable, gonna call it maybe timer handle is a good name for it, and I want to clear this in here. So I'm gonna get the timer handle. So when I either lose or probably win as well, I want the timer to just freeze, to stop. So I want to do exactly that and just clear and invalidate. This is the name of the node we want. And I'm just gonna duplicate this because I want in both cases. And now with that, I want to make sure that this the clearing happens both when I win and when I fail. So let me try to just run first to the win. It's a bit short, but okay, I didn't manage. It's still at -3. But maybe we can put a condition here. Probably good to do actually. So I want to say something like, if this number is less than 0, right? So when the timer kind of elapses, I'm gonna do a branch here. A quick way to do a branch is just pressing B and clicking. Also very nice to have. Gonna connect it here. I want when the timer is bigger than 0, so the false, to still update it, right? Because I think that's important. But when the this timer runs to 0, under 0, 0 or under, to do show the lose. So let's actually test this. We still have the timer going fast. So now you see the timer froze at 0, which is exactly what we want. I'm also gonna try again to quickly sprint to that. Well, you won at 0. That's a little bit janky because we can try to decrease this because This is pretty much like an edge case at this point. And you won. And again, the timer froze at 27 because we cleared it. Also, some small bug we can probably tweak. If I press restart, you'll see it starts at 0, 0. I kind of don't like that. There's multiple ways to fix it, but one kind of fast way is to, expand this set timer by event and put this to -1. And now you'll see it looks a little bit better, right? You can kind of still see 0, 0 for like one split of a second, but looks a lot better now. So, okay, we talked about clearing things that go over time, like, timers, and I said tick. We're actually not going to use tick in this presentation at all in anything we do here, but since it's such a common concept in, I think, all game engines, we should discuss a little bit about it. So I'm going to do tick, and we have an event called tick. The simplest way to explain this one is that it does work like a timer, and it still works every second, but it works every second multiplied with the amount of frames that you have on the screen. And frames is pretty much all these, all the moving images you see when, things get rendered to the screen. And most games run at 30 or 60 FPS, so you can imagine this runs a lot. But, don't just trust me blindly. Let me show you that this is what happens. So if I connect just a print string to the tick and I press play, pressing nothing, doing nothing, you see hello is being triggered all the time, right? So this is pretty much what tick does. Tick takes things and runs it continuously. This is a very powerful thing, but with power, with great power comes a bit of responsibility. So although you should use tick whenever you need it, be mindful to not overload the tick. Don't put a ton of complex events here because this will affect your performance. Okay, so with that, what else we can do? We probably want something like when the timer is completely out. So when it reaches 0, I want my input to no longer function, right? So I can sort of get some feedback from the game that, something happened. So with that, I want to, if you remember, before in the controller, we had this part. You remember we just disabled this part and no inputs worked. And as we worked further in the inputs and we did our own, we know that the enhanced, the mapping context and this enhanced input local player subsystem is what actually makes these things happen. So I'm gonna use this knowledge again to make some custom events that allow us to do exactly that. So I'm gonna add a custom event here. I'm gonna call it disable move input. And I'm gonna paste this here. And I'm not just gonna add a mapping context. I'm also gonna remove a mapping context. And let me explain why I'm doing this. I want all my inputs to, all my specific movement inputs to stop working, but I want one to still be active. I want the game to still be in a controllable way from that fail state that, for example, you are still able to restart. So exactly that's what we're gonna do. I'm gonna go back. For now, I'm gonna leave this and I'm gonna go back into my input, gonna just duplicate the IMC default, and I'm gonna call this restart only. So hopefully you can already see where we're going with this. If I want to leave just restart here, I'm gonna delete everything else but restart. So with that, I leave just this specific one that has only restart, and that's my only function that I have. If I go back to the controller, I'm gonna do like so. So when I disable it, I want to remove the defaults. So I don't want to be able to move anymore, but I want to add the restart. And I'm also gonna do an opposite of this, which is the enable move input, because I want at times to be able to pretty much do the polar opposite, right? And I believe this will be something we'll reuse a few more times than just this time. And this is why we're creating, these events. So we're making it as modular as possible. And here, this will be the opposite. I want to remove restart, and I'm going to want to add the default. Great. So now coming back to where we discussed we want to implement this is in the HUD. And in here, I want, when I lose, to disable my input. What I need for this, you probably remember the sequence from where it was in the controller. The sequence just allows us to add sort of multiple execution pins. So it allows us to, make it a bit more tidy. And what I want here really, because I did all of this, this stuff in the controller, I want to be able to access the controller, and I want a casted version of it. So I don't want to cast every time I'm doing this, but I want to have a saved one. So again, I'm getting the controller, get player, controller. Oh, not from the node, get player, because that's just you see some nodes are like this. They don't have like a pin, an execution pin, and these are called pure. And anything that has like an execution pin, it's called impure, and it needs to do a verification to check. So that's kind of how you can think about it. Yeah, I want to, as I said, cast to controller. Make sure you select the proper one. We want to promote this. I want to call this controller ref, probably connect it here. Gonna leave that there. And here, this is my lose UI. I want to just do exactly that and disable the move input. Great. So let's see. Actually, let's update the time to, again, be very fast, so we don't need to wait too long. And I'm just moving around. And now I'm pressing the keys. I can still move around because I didn't remove that. I just removed the stuff. And if I press R, the game still works. I can restart, right? So that's a very nice way to disable the input via the mapping context. Okay, so I think right now we are done with both win and lose. And the last part is the challenge. And we're in the final stretch now. We almost have, our working red light, green light. But let's actually take the red light, green light part into the editor. So we want to, you remember from the TV show, you had this doll that kind of rotates. This also kind of warns you when the state will change. And we're going to actually emulate something like that. So I'm going to go back into blueprints, right click here, blueprint class, actor, pp underscore. Let's call it state changer, maybe. And I want some visuals to this. I'm gonna add a skeletal mesh. Skeletal mesh is like a static mesh, but a bit more advanced, more specific, used for animations and such. I'm gonna use just something basic from the engine content. I don't want this to be, I'm gonna compile so I get the material. I want the yellow not to pop out because I want something else to pop. So I'm gonna show you what. I want just a default material. And here I want the just another cube. This is again a static mesh. I'm gonna lock the scale here and put it 0.5 so it scales all of them at once. Also very nice to know. And I'm gonna just attach it to its head. Let's maybe put some color to this because we're talking about red light, green light. Let's start with green. And with this, I want to place it in the level and check it out. Let's see. So I'm going here. I'm putting on top of where my wind trigger is. I'm gonna rotate it, maybe like so, and maybe scale it. So I'm pressing R, picking all the coordinates and just the other way, making it a little bit bigger so you can see it from afar. Great. Now we are gonna do something very similar to what we did before. So hopefully this, you get into the vibe of sort of how we can do some of these things. And I am gonna go to the event graph And I'm gonna delete these two just to clear, to make the space. And I'm gonna do set timer by event. I want this to run maybe every 6 seconds. I'll explain shortly why 6 seconds, right? And with this, I want to just create an event and say state changed, specifically because I want this to go back and forth. So it goes to green and then to red and then to green and then to red. So this is a constant kind of back and forth. We have a very specific flow control node, as we talked about in the previous chapter. We only used branch and sequence until now, but here's another one. It is called a flip-flop, and hopefully it's a bit clear what it does. Every 6 seconds, the first time it will do A, then after 6 more seconds it will do B, then after 6 more seconds it will do A, and so forth. So this kind of goes back and forth. And we're also gonna introduce a new concept here, because I don't want just the color to change, the cube, the head, this cube, maybe state change cube to change. I want also the, as it was in the TV show, to rotate, right? Because the rotation actually warns you a little bit, and I think that's a nice touch. So I'm gonna add a concept called a timeline, and the last one is the one we want. Let's just call it timeline, it's fine. And I'm gonna connect the first one into play from start and the second one into reverse from end. And you will see in a second, this will make a lot of sense. If I open the timeline, I want to add just the flow track. This will be very simple. The timeline really lerps, linearly interpolates between two values. And you might ask, what's a lerp? What's linear interpolate? Well, it's basically when something smoothly goes from one value to the other. So for example, between our values here, I would like to have just 0, 0. So 0 the time, 0 the value, and then the time after 1 second, I want the value to be 1. So what happens when we nicely interpolate between these two? Instead of just going from 0 to 1, so imagine the rotation will just be in one frame, it will just flip. I want it to slowly rotate, right? And that is what linear interpolation is about, and the timeline will help us with this. Instead of from straight 0 to 1 or 1 to 0, it will do 0.1, and then over time 0.2, and then 0.3, and so forth. And in order to make it a little bit nicer, you can just click the first point here and press 1. Right-clicking would also get the multiple values here of how the curve will look like. So you see it starts a little bit slower, and then it ramps up, and then it ends up a little bit slower as well. That gives a little bit of game feel. And probably I want to name this, regularly we call this an alpha. We can call it lerp alpha, right? So we know it is lerp stands for linear interpolation. And I want to do this in a lerp. As I said, I want rotation, so I want a rotator. The difference between a vector and a rotator is that a vector, it relates to the coordinate system that you saw before, that we kind of move things around, and here it refers to the pitch and yaw and so forth, the properties of rotation. And I want this to be applied to my skeletal mesh, which is pretty much the guy that holds this cube, right? You saw I parented the cube under. And rotation, set relative rotation. Set relative rotation, right? I want it relative, it's just inside this specific object, so it should be fine. I want to run this on update, right? So every time it sort of moves a little bit on that curve that we saw here. Every time it does that, it also updates, it goes between these two values. So it slowly goes to 10 angles and, to 20 degrees and 30 degrees and up to 180. That is all fine and dandy. Let's test it quickly. I'm going to put 2 seconds here so it's a bit faster to see. And you'll see now we sort of emulate, okay, we forgot to change this this loose condition to make it a bit slower. So I'm gonna put this back to 1, and I'm gonna go back here, and it works. Let's put it back to 6 seconds. So hopefully also you realize why I left 6 seconds here. It's actually still 5 seconds, but I want 1 second of warning whilst the timeline is updating. Okay, so with that, we have that part, but of course we still want the cube to also change color. And again, from a timeline, we have something perfect that just allows us to do this quickly. We have direction here. So as you see, we have, play from start, reverse from end, and we have actually 2 directions, forward and backwards. So first it will go 0 to 1, then 1 to 0. And I want to just write equal, equal. This will allow me to sort of compare it with what values are inside of this. And as you see, we have forward and backward. So I'm going to do a branch by holding B. And then, as I said, forward is, if forward is true, well, it's going forward. If forward is false, it's backwards, right? So it's easy for us to do this. I want to connect it to finished. I don't want this to run whilst it's updating. I want when the state is fully done, that's when the state change cube should update. With that, let's take the state cube change and let's do these 2 set material, right? Because I want to change the color of this. So when it's true, when it's going forward, it is red. And vice versa, when it is the other way, it is green. So 1 false, 1 true. I'm gonna take this a bit together here, can make it a bit nicer, tidier. Okay, and now we can probably play it. I think I put it at 6 seconds. Let's put it to 2 again, so we can quickly test this. So it's green. Now it's still green. What did we miss here? So we connected direction. We checked this one, the cube. It has, yeah, it is correct there. Let's see what we had there. Then the last one. Yeah, I think that seems correct. But what we didn't actually do, which is probably not as obvious, is that we did this every second, 180 forward, red. Okay, that seems correct. Let's try it again. Did I actually think this should have? So one is red, one is green. So when it goes forward, it turns. So it should be red. I missed something here. Okay. So it seems like what we forgot to do here, very important, is in here, you see the length of this entire timeline is actually 5 seconds. We're just using the 1 second, but the game is expecting the full duration to be used. So we either modify the length to be 1, or we use the last keyframe, which means that it will cut, the duration up to a second. So either putting 1 here or changing this to enable it using the last keyframe will help us. So again, this is how we learn, by making mistakes. This is the way we go forward. So as you see now, right, when it rotates in between the states, that is kind of how it works now. So that's great. We go in here, we put it back to 6, because that's sort of what we wanted. And with that, we have the the red light, green light part. But now I, of course, still want to make sure that when I do these states, it actually takes some effect into my player as well, right? And first, maybe before we even do that, is maybe we would like to ensure that this event here, I have this, you know, the not this one, the color of the cube, I actually have access to what does the game start from. Should it start from the green state or the red state? So I'm gonna go in the construction script because we never actually used the construction script, or we didn't use it much until now. And I'm gonna add the local variable. I'm gonna call this red light, green light. I'm actually gonna tell it is red state, like a question. Is it the red state? I'm gonna drag and drop it here. I'm gonna do a branch, and actually I just did a local variable, which is also fine. A local variable is something that it's accessible only to itself, and that's perfectly fine. We can also make it in the variable section if we want, but if you want to keep things only for this particular thing and non-accessible to anything else, you can use a local variable. So here I want to pretty much copy paste what I did here and put it in the construction script, and you'll see what the construction script actually gives us. So if it is red, it should be red. If it's green, it's green. So here I'm also gonna make sure that I actually can't use this for our case, because if it is a local variable, as we said, we don't have access to anything else. So I want it to be here because it is red state, because with this I will be able to do something that I want, which is instance editable. So if I click this little eye, or if I click this here, expose on spawn will be important if I would spawn this in the world, but for us, we already placed it in the world, so it's not spawned. And this does exactly this. So let's look here. Let's click on our guy. He's already selected. So if I do is red state and I change it, then you see it without even playing, this updates. And then it goes back. If I would do this in the begin play, this would not take effect until I actually click play. This is the power of the construction script. It runs, as I said, very early, and if you want to see the changes directly in the editor, very, very useful to use it there. So I'm going to leave it to green because I still want green. And let's go to kind of the last part, which is actually applying these red light, green light parts into our player. And with that, I want to do just that. I'm going to go back to our pawn. Pawn is here. And in here, the first thing I would say, because we actually didn't use the camera like at all, and I want to give some love to the camera as well, let me show you something we can do that would add a little bit of, of flavor to this. So if I go into follow camera and I scroll down here and I do color grading in the post-processing space category, and I go global, and let's say I take gain, I enable gain, and I put this to some crazy green, you will see that all the camera is tinted in green, right? That's a very strong green, but you probably can make the connection between the two now. We want, when it is green state, for the camera to tint a little bit green. When it is red state, for the camera to tint a bit red. This will help the player also tell what state they're in, even if they're not pointed towards this state changer, right, with the cube on its head. So that would be a really nice thing to add. So now we know that this is here. I'm gonna reset. The numbers we have here is what I'm gonna use, so it's important to remember that this is where I sort of take these values from, more or less. And I'm gonna do exactly that. I'm gonna take the follow camera, drag and drop it here. I'm gonna get the post process, right, because it was in there, get post process settings, and then I'm gonna set members in the post process, because there's a bunch of things here, and inside this one I just want the gain. I believe it was the global grading gain. Yep. So now I expose this, and I want to just promote it to a variable. I'm gonna call this green. Gonna compile it so I can see the values. Gonna remove gain, and with this I will, because it's green, I don't want it to be as strong green as it was in our test, but I want it to be a little bit milder. So I'm gonna put a bit in the other colors. Again, we're talking RGB there. Then green should be 1. This was 0.5. 1 at the end is fine. And let's test it out by connecting to our begin play. So you see, it is a nicer tint of green. Awesome, that's what we wanted. And I also want to duplicate this and make a red, compile it, and then I do the polar opposite, RGB, red is first, right? So then I put 0.5 here, and I'm also gonna test it just to make sure this works just fine. Okay, now it is red, awesome. So with this, I know it works, and I'm gonna make two specific custom events with this. I'm just gonna probably take this with me, and I'm gonna go down here. I'm gonna make one custom event, which is called a red state. And when the red state is happening, I want my screen to be tinted in, of course, not green, but red. And I'm just gonna drag it there. And I want another one, which is called green state, to be pretty much the same thing, but of course with green. So with that, we put it there, and we have yeah, these two things. And I just don't want, I don't want only this. I also want, when I am in the red state, I cannot move anymore. You remember we did something in the player controller to prepare us for this, which is these two. And again, I'm reusing it maybe like a third time now. This is, you know, the smart way to kind of build reusable things. So yeah, let's use it again in our pawn. I think my pawn was here. I have a lot of things here. Probably we don't need as much, so probably we can close some of those. And here I want the player controller. So because of that, I'm just gonna get the controller, like, you know, cast it, get player controller, and then cast to BP, third person controller, connect this to here, and then make this variable ref controller ref, and with that I will do just like so. Oops, just like so. Here I'm gonna do disable move input. I don't want the default input because I don't know what that does. Probably does something similar, but we have more control over the one we just made, so that's probably better. And here, when it is green, of course I want to be able to move. So let's try this out. I'm gonna also go back into the HUD, which I think I closed. Let me see. The HUD is here. I want this to be, not the HUD, sorry, the state changer. Yeah, the state changer, I want this to update maybe every 2 seconds, so I can quickly test this. Right, so right now we pretty much made those, but we forgot to actually connect it to the state changer here where we actually needed them. So we probably want that. I'm gonna cast the player, get pawn, get the player pawn, and then cast to BP third person character. And here I'm gonna connect it. I'm gonna also call this variable, promote it. And with that, I have it. Oops, I have it here. I'm gonna call this pawn ref. And in our space here, when we actually have the red state, I want to just call that. So I'm gonna get it, and then I'm gonna call state red state, as we called it, and then do the same, and then state green. Right, so we know. And now let's try it out. So it's green, great. It's red. What? I can't move. I'm pressing all the buttons. Doesn't work. It's green. I can move. Great. Red. Can't. Awesome. And with this, we pretty much will add one last bit. And this last bit is maybe a penalty for overusing the run, right? So we added the run, but maybe, you know, right now you can run all over the place with no sort of penalty. And I would like to sort of limit this a little bit. So if I go back into my character and I go to my run here, I just want to do something. It's already very easy to do because of these enhanced inputs. So I have elapsed seconds. This is the time that was spent since this was triggered. And if it is greater than maybe 2 seconds, I want a branch holding B, connecting the branch and connecting it here. I want this branch to do from the ref exactly what we did before. Now it's probably the 4th time we used it. Again, very handy to just have something that just works and allows us to tweak the functionality very fast and add functionality. I'm also not going to use a timer here, just to keep it very simple. I'm going to use a delay. A delay, as the name would imply, it's pretty much what it says. It waits for 2 seconds and then it does something. So I want it to be disabled and then I want to be enabled again after 2 seconds. And if I want some sort of indication that some state happened, I'm just going to use a print string in the case here. I'm going to say fatigue. And actually, I'm going to go at the start and press Shift Enter a few times so it doesn't overlap with the timer that we have in the corner of our screen. 2 seconds is perfect. Let's make it into some red. And with that, let us see what we have here. So if I shift, it says fatigue, right? Perfect. And I shift again for 2 seconds. Okay, it caught me in the red state. Let's actually put the values back to where they should be. So the state changer, I want this to be 6. And I want that to be maybe 30 seconds, right? So I press shift. So fatigue, right? You see it under the timer. And now it's red state, right? And again, I can see the red state without even looking at the guy because I have this colored screen tint. And again, I press shift, fatigue. So with that, probably the last thing you'd do, which helps a lot with how the game feels, is change these level bits. You can add your own and delete some and move some around, so it makes the level a bit more interesting than just like a straight line. But really, since this is a bit out of the scope of the gameplay framework, this is something that I won't do as much here. But yeah, changing where things are, where what obstacles you have in front of you can really help sort of change the outcomes here, right? So you already kind of see some stuff I need to avoid. Oh, I'm fatigued, I need to wait. Maybe we can reduce this to 15 seconds, right? And yeah, with that, I would say we have our last chapter completed. I will go into the timer, remaining time, and put this to 15. And probably this is a little bit more of a challenge now. I have 15 seconds to get there. I'm sprinting. Oh no, I'm fatigued. And now I move again and it will go to red again. 7 seconds, so close. So now it plays a little bit nicer. Okay, so with that, we are actually complete. Good job for going through all of this. To recap, we taken the framework knowledge into practice. We learned how to problem solve in ways that we can create also reusable logic, and we integrated everything into this small game prototype. Where would you go from here if you want to expand a bit deeper on your knowledge? You can try these steps yourself. You can try to sort of reproduce, see what flavor of gameplay. You can take kind of existing things we did and mix and match them in different ways. Almost all the techniques we have gone through, they're interchangeable and modular. So how would you use the gameplay framework? Then you can try to find some other game, TV show, comic book, etc., and break it down, see what would work well into a game. What game or what thing would you like to deconstruct the most? Then, since this is in no way an exhaustive information on the framework, but a simplified one, you can have the, you can look at the complete framework docs. You can just scan this QR code and it will take you straight to the official documentation. And if it sounds like a no-brainer, this is strangely an underused and underrated skill that you should use and use it often. Asking questions is like the primary engine, pun intended, for learning, critical thinking, building deeper connection to the information you seek, active engagement, clarifying any doubts, challenging assumptions, identifying the right problem statement are just a few of the things you gain simply by being inquisitive. And don't forget, learning should combine challenging yourself with something you enjoy. Don't forget to add that special something that magnetizes you closer to your objective. I enjoyed a ton building this path for you, and I hope you find it useful and hopefully found some fun ideas to spice your creativity. Thank you. 감사합니다.